Hey everyone, welcome to the video. Today we're diving into the CMOS inverter. We'll start by looking at the CMOS elements that make it work, and then we'll discuss how it functions, its different regions, and how it's built. Now let's take a look at the logic table for the CMOS inverter. This table shows the relationship between the input and output states. It's really simple. When the input is high, the output is low, and when the input is low, the output is high. We have a plot showing the relationship between the CMOS input and output. We can see key points marked here. V output high is the minimum voltage for a high output. V output low is the maximum voltage for a low output. V input high is the minimum voltage that's considered a high input. V input low is the maximum voltage for a low input. And Vm is the voltage where the input equals the output. This plot helps us understand the switching behavior of the CMOS inverter. Now let's talk about how to build a CMOS inverter. It's actually pretty straightforward, but we'll break it down step by step. First, we need an N-type MOSFET. When the input is high, a channel forms between the drain and source, allowing current to flow and pulling the output low. But when the input is low, no channel forms because the gate source voltage is less than the threshold voltage, VGS less than VT. Second, we need a P-type MOSFET. When the input is low, a channel forms between the source and drain, allowing current to flow and pulling the output high. But when the input is high, no channel forms because the gate source voltage is greater than the threshold voltage, VGS greater than VT. We can see from these tables how the currents behave in the different regions for both the N-type and P-type MOSFETs. In the cutoff region, the MOSFET is off and no current flows. In the triode region, the MOSFET acts like a resistor, allowing current to flow between the source and drain. And in the saturation region, the MOSFET is fully on, with the current flowing at its maximum level. These tables give us a better understanding of how the MOSFETs operate in each region. Now, when we connect an N-channel MOSFET and a P-channel MOSFET together in the right configuration, we get a CMOS inverter. Here we can see the CMOS inverter circuit. This is the basic structure that uses both N-channel and P-channel MOSFETs to invert the input signal. Let's apply a high input voltage. Notice that VGS greater than VT. This turns the N-channel MOSFET on and the P-channel MOSFET off, which pulls the output low. On the other hand, with a low input voltage, VGS is less than VT. So the N-channel MOSFET turns off and the P-channel MOSFET turns on, pulling the output high. And that's how the CMOS inverter works. By switching between high and low input voltages, it inverts the signal at the output. Alright, that's it for today. Thanks for watching, and don't forget to like, subscribe, and hit the bell for more videos. If you have any questions, I'd be happy to see your comments below. See you in the next video.